2. The basic idea. Underlying the method of formal derivations is the following fundamental idea. Granting the validity of a few selected argument forms, we can demonstrate the validity of other argument forms. A simple illustration of this procedure might be useful. In an earlier chapter, we used the method of truth tables to demonstrate the validity of numerous arguments. Among these, a few stand out for special mention. The first, and simplest one perhaps, is the following. MPPQP. Q. This argument form is traditionally called modus ponens, which is short for modus ponendo ponens, which is a Latin expression meaning the mode of affirming by affirming. It is so called because, in this mode of reasoning, one goes from an affirmative premise to an affirmative conclusion. It is easy to show that MP is a valid argument, using truth tables. But we can use it to show other argument forms are also valid. Let us consider a simple example. A 1PPQQR. We can, of course, use truth tables to show that a 1 is valid. Since there are 3 atomic formulas, 8 cases must be considered. However, we can also convince ourselves that a 1 is valid by reasoning as follows. Suppose the premises are all true. Then, in particular, the first 2 premises are both true. But if P and PQ are both true, then Q must be true. Why? Because Q follows from P and PQ by modus ponens. So now we know that the following formulas are all true: P, PQ, Q, QR. This means that, in particular, both Q and QR are true. But R follows from Q and QR, by modus ponens, so R the conclusion must also be true. Thus, if the premises are all true, then so is the conclusion. In other words, the argument form is valid. What we have done is show that a 1 is valid assuming that MP is valid. Another important classical argument form is the following. MTPQQ. P. This argument form is traditionally called modus tollens, which is short for modus tollendo tollens, which is a Latin expression meaning the mode of denying by denying. It is so called because, in this mode of reasoning, one goes from a negative premise to a negative conclusion. Granting MT, we can show that the following argument form is also valid. A 2PQQ or R. P. Once again, we can construct a truth table for a 2, which involves 8 lines. But we can also demonstrate its validity by the following reasoning. Suppose that the premises are all true. Then, in particular, the last 2 premises are both true. But if QR and R are both true, then Q is also true. For Q follows from QR and R, in virtue of modus tollens. So, if the premises are all true, then so is Q. That means that all the following formulas are true: PQ, QR, R, Q. So, in particular, PQ and Q are both true. But if these are true, then so is P the conclusion, because P follows from PQ and Q, in virtue of modus tollens. Thus, if the premises are all true, then so is the conclusion. In other words, the argument form is valid. Finally, let us consider an example of reasoning that appeals to both modus ponens and modus tollens. A 3PPRQR. Q. Suppose that the premises are all true. Then, in particular, the first 2 premises are both true. But if P and PR are both true, then so is R, in virtue of modus ponens. Then R and QR are both true, but then Q is true, in virtue of modus tollens. Thus, if the premises are all true, then the conclusion is also true, which is to say the argument is valid.